Okay, this is 7.1 homework. These problems, the first problem gives us these systems of equations right here. We got three equations with three variables, and they want to know if there's a unique solution, one solution, if there's no solution, or if there's infinitely many solutions. So what we're going to do, the easy way to do these, and we're going to stick with the easy way for now. I will show you how to do this by hand later, but I don't know if I'm going to test you over that because we're kind of running out of time, and I just want you to give you the basics for now. So the easy way to do this is to put it in your calculator as a matrix. Okay, so we're going to put the coefficients in as a matrix, and we're going to call this an augmented matrix. So we're basically going to take all the numbers and dump it into a matrix. So let's go to second matrix. We'll go to edit, and I'll put this in as matrix A. So I'm going to put all the coefficients here. This is going to be a 3 by 4, 3 rows, 4 columns. And I'm just going to enter in all the coefficients. So 1, 2, 3, 1, 4, 5, 6, 1, and 7, 8, 9, and 1. So all the coefficients are dumped into this matrix. Now what I can do is I can go to second matrix math and scroll all the way down to row reduced echelon form right here. And then I'm sorry, I gotta get out of this first. Go back to my home screen. Now do second matrix math. Scroll all the way down to row reduced echelon form. Then go to second matrix and choose matrix A. And hit enter. And it gives you this matrix here. So what this means is that I have this original matrix simplified into row reduced echelon form. And so if I plug in the variables back in, I get this equation. X plus 0y plus negative 1z equals negative 1. The second equation becomes y plus 2z equals 1. And the other equation doesn't matter. There's nothing helpful there as far as the numbers go. So we have these two equations then. So with this system right here, there's an infinite number of solutions. If you think about just plugging in a number for z, you'll get a solution for x, you'll get a solution for y. You can just plug in a different number for z and get another order pair for x and y. So there's an infinite number of solutions for x, y, and z that would solve this system. So we're going to say infinite number of solutions there. All right, so for the next one, I'm going to do the same thing. I'm going to put this matrix in. So you can go ahead and do that. You can go to second matrix. I'm going to put this in under matrix B now. So scroll over to edit, scroll down to B, and enter another 3 by 4. And then just enter in the coefficients. All right, I've got it entered in, and so then I can do second matrix math, scroll down to row reduced echelon form, and choose second matrix B now. All right, now if I hit enter on that, I get this one, which is right here. Now if I replace that with the variables again, it means that I've simplified this to x plus z equals 0. And the second equation becomes y plus z equals 0. And the third equation becomes 0 equals 1. Now that's an issue, 0 equals 1. That's a contradiction right there. So that means no solution. So I would put an n here. All right, I'm going to do the same thing for the last one. Enter that in and do row reduced echelon form. I'm going to put this into matrix C now. All right, so when I evaluate that, I get this here, which if I put the variables back in means x equals negative 1, means y equals this really small number, and it means z equals positive 1. So that's one unique solution. So we're going to put a u there. All right, the next problem is a little tricky. I've written the three equations here for you. Let me go through how I did it. First equation says that we're going to receive this much money total, so I put that there. And there's three different types of investments. We have stocks, bonds, and CDs. So I did it in this order, in the order they gave it to me in. Stocks, bonds, and CDs. So the total amount there has to add up to the total amount given. So that's how I wrote the first equation, obviously. Now the second equation is an interest equation, so 0.069 is the 6.9% that's invested into stocks. I kept it in the same order, S, B, and C here. plus the 4.4% invested into bonds, plus the 2.25% invested into CDs equals the total amount of interest, which they gave me right here. They called it annual income from investments, which means interest from investments. So there's the interest equation. And then the last equation, they said Country Day invests this much more in bonds than CDs. So this much more in bonds than CDs can be a little tricky to write, but there's more in bonds, which that means that I'm going to add that number to CDs to get the bonds. So double check that, because whatever you stick in for C, you would add that to this number to get a larger B value for bonds. Now, these equations are all, if I put them in standard form, I can put in my calculator. So what I do is I go to second matrix, and then edit. I'm going to edit this into matrix A, 3 by 4. And I enter these in. So the coefficients for the first one are 1, 1, 1, and then you have to enter this whole number, which I know takes a while. You have to be careful about that. But I did enter in that whole number. And then the next equation is in standard form already, so 0.069 plus 0.044 goes in right just like that. And then the last equation is a little tricky because it's not in standard form. So if you put it in standard form, you have 0s, and you move this over, you'd have 0s plus 1b minus c equals this big number right here. So that's what it is in standard form. That's why in the calculator then I entered it in like this, 0, 1, negative 1 for the coefficients here, and then the number they gave me, which is this big number here. Now from there I did second calculate, so I got out of there and did second matrix math, row reduced echelon form of matrix A, second matrix A, hit enter, and this gives you the answer. So the 1 here stands for the coefficient on S, which means S equals 72,813. So let me show you this right here. These are my answers right here, 72,813.5. I don't know how accurate you need to do this. You probably do it to the 10th and it should work. This second one represents B, which is 55,231.7, and the last one's 37,000 about. So that's how we can solve that pretty easily in our calculator. All right, the next problem now gives us 3 systems, and it wants to know the same thing: if it's unique, one solution, no solution, or an infinite solutions. So we could do these with matrices in our calculator. We could also do this by hand because this is easy enough. 2 by 2s are easy enough to do by hand. This one's already set up for elimination. If you add them together, you get 6x equals 2. Divide both sides by 6, you get x equals 1/3, 2/6. So if you plug that back in into either one of the equations, 1/3, you get y equals 0 then. So there's my unique solution, so that's unique. But we could also do this in the calculator. If you go to second matrix and then you scroll over to edit, matrix A, I'll put this in. I want to do a 2 by 3 this time, augmented matrix. And this is going to be 3, 4, 1, 3, negative 4, 1. Now I'll quit out of there and go to second matrix math, row reduced echelon form of matrix A. That gives me the same answer, x equals 1/3, y equals 0. One unique solution. All right, the next one, you could multiply this top equation by -2 and you get -6x plus -8y equals -2. And when you add those equations together, you get 0 equals -1, which is a contradiction, which means no solution. And like I said, you can enter these into matrices in your calculator, you'll get the same thing. And then the last one, do the same thing, multiply the first equation by -2, you get -6x plus -8y equals -2. And so now I've replaced the first equation with this equation, and then when I add them together, I get 0 equals 0, which means infinitely many solutions because 0 always equals 0. So, and you will get the same thing if you enter these in the matrices. Okay, if I'm going to solve a big one on my calculator, like this system here, just go to second matrix. We're going to go over to edit. This time I'm going to make this row by column. So we got 4 rows and 5 columns, so it's going to be a 4 by 5. and then enter in all the coefficients. Once you get it all entered in, go to second matrix, math, row reduced echelon form of matrix A, and it gives me my answer. X is -10, Y is -17, Z is 6, and W is 9. Okay, the next one, go ahead and enter this into one of your matrices A in your calculator, for example. It's a 4x5. Enter in all the coefficients and do a row reduced echelon form. And what you'll get is this matrix right here. You can actually hit math fraction too if you want to turn these decimals into fractions, which I think is a little easier. And you get this right here, which if I substitute back in my variables, this equation right here becomes W plus 0x plus 1/3 y. And they want this solved for W. So I guess I can do this, well, let me finish writing it down, I guess. Plus Z, so this would be 2/3 Z, equals 7/3. And the other equation here becomes 0W, 1x, plus, and then there's y, so it'll be -4/3 y, and then z plus 7/3 z equals 5/3. So there's my two equations. Now they want them solved for w, so you're going to have to move both these things over to the right with a minus sign, with both of these too as well, and enter those equations in for w and x, and that will be your answer. Okay, this next one should be pretty easy then. It says find two numbers whose sum is -2, so a plus b is -2, and the difference, a minus b, is -6. So you don't need to do matrices for this. This is easy enough just to add them together and get 2a equals -8, in which case a equals -4. And if you plug -4 back into any one of these equations, you get b equals 2. So your answer is -4, 2. This next one wants to use substitution. So if you remember, I can take the first equation and solve it for y, for example, and I get x minus 4. And I could sub that in right here, which gives me 4x minus 3 times this equation, x minus 4 equals 15. So then I can distribute this. I get 4x minus 3x plus 12 equals 15. Subtract 12 from both sides. That leaves me with a 3 here and 1x on this side. So x equals 3. I can then plug that back in up here and get y equals -1. So those should be my answers for x and y.